them.
I don't know what I would do without you students, because you're the ones who keep me teaching properly. Okay. Was Melissa able to get on? I see Melissa is still not on. Hmm. I don't know why she's having a hard time getting in. You know, I love the computer and I love Zoom, and as long as it works properly, it's great. But when you have a glitch and it doesn't want to work the way it's supposed to, then you're really in trouble. That's the big problem with computers. Okay, let's go to this second equation. So in our first equation, we put it in, let me just repeat what I said. We took the log base 2 of 128 equals x and put it in exponential form, and then figured out, it said 2 to the x equals 128. X is our exponent. We're looking how many times do we have to multiply the 2 to get up to 128. And again, I just did it with my fingers and kept multiplying 2 until I got to 128. And I saw it was 7 times that I multiplied the 2. So my x, which is my exponent, that's what my log is. The exponent is equal to 7. My answer here would have been 7. Now, looking at this second equation, this is also an equation that has logs in it. But the problem with this equation is here we just had one log on a side. Here we have 2 logs. And our rules for switching from the log format to the exponential format only work when you have just the log written once. So if you recall, what we did is we changed this, we contracted this back to a single log. Remembering in our rules for working with logs, when you're subtracting logs, you remember, subtracting logs means you're subtracting exponents, and you're subtracting exponents when you divide. So you can contract this back to a single log, put it back as a single log by writing this as log base 3 of the x plus 3, which would be on the top, divided by the x minus 1 on the bottom. Because you're subtracting this log minus this log means you're actually, of the numbers, the x plus 3 and the x minus 1, you were dividing them. And now that you have this back to a single log, you can now do what we did over here and go from the log format to the exponential format. In this case, my subscript is 3, so that becomes my exponent. That becomes my base. The number on the other side is the 1, that's my exponent. And that equals the x plus 3 over the x minus 1. We have switched this from a log equation to a regular algebraic equation. So 3 to the 1, of course, is just 3. And this is equal to x plus 3 over x minus 1. And to make it look easier, I'm going to put the 3 over 1 so I can see that it looks like a proportion. I can cross multiply. The 3 times the x minus 1 equals the 1 times the x plus 3. And when we remove the parentheses, when we distribute, we get 3x minus 3 equals x plus 3. And I'm going to subtract x from both sides, which will give me 2x minus 3 equals 3. And then, of course, this is just regular algebra, just regular linear equation, 2x equal to 6. So I get that my answer for x is 3. Now, before I say that that 3 is a good answer, I have to go back to my original log equation and substitute the number 3 for the x. So if I subtract 3 for x over here, this will be 3 plus 3, which is 6. And here this would be 3 minus 1. My x is again 3, which is 2. I don't have to do any further checking, though I could, but all I have to know is that the numbers that are taking the logs of, the numbers that are next to the word log, have to be positive numbers. And 6 is a positive number, and 2 is a positive number. Usually when that number is positive, it works, and when it's negative, it doesn't. But really, that's not 100% the case. You really have to check to see if what you're finding the log of, the number that's next to the word log, the one that's in the parentheses, has to be a positive number. This is, so 3 is the correct answer. Does anybody have any questions about either of those questions?
Professor.
Yes.
April asking if you could let her in.
Thank you very much. I'm in now.
Okay, you're coming. Okay, all right. Sorry about that.
I don't know why people are having trouble getting in. I really don't know. We're different about today than any other day, but I don't know. Yes, Ashley, we are going to be going over the whole trigonometry and Pythagorean theorem a little after I finish this up, the second half of the period, okay? Because I remembered you'd asked about that, so I said we'd do it today. Okay, so let's just do 1 or 2 more examples with logs. Things of the type you might see on your exam, on your final exam. Everybody okay that I erase this? Okay. Okay, I'm going to put 2 more problems on the board, and while you're trying them, I'm going to take attendance. So here's problem number 1. See if you can figure this out. See if you could figure out what x is. Okay, see if you can figure out what the x is in this case, and here figure out what the log of 216 and base 6 is. Well, I take attendance. Zia?
Yes.
Good morning.
Lily.
Nashia Allen. Nashia? Anna Belkis. Emma. Emma Benedict. Messiah. We're not doing too well today. Corey. Corey,
I'm here.
good morning.
Morning.
April, I know you're here because I heard you before. Khadija. Khadija here. Umar. Yakima. Cheryl, I know you're here. Stacy, I know you're here. Denisha. Devana. I thought I saw her here before. Devana. Okay. Natalie. Erica.
Good morning, Professor.
Okay, good morning, Erica.
Good morning, Professor.
Who just said good morning just now?
Erica.
Erica. Good morning. Jonathan, I know you're here because I spoke to you. Luke. Luke. Layla. Ashley.
Good morning.
Good morning. I knew you're here. Okay, so we're going to do that whole Pythagorean. I think you made the trigonometry as well, right? The sine.
Yeah.
Yeah, and we're going to review that today.
Okay, thank you.
Kachira. Kachira, I see you're here.
Here.
Good morning. Jennifer. Jennifer, I know you're here. I spoke to you. Rachel Seeley. Okay, we don't. I wonder if people are having trouble getting on. Good morning, Luke. Okay, I'm gonna mark you here. I'm just checking my emails to see if anybody was having trouble getting on. Okay, let's see anybody here. Okay, I see we have answers. So let's see if we could go over these two questions. First of all, number 1, it says the log of 5x equals 2. And we always expect to see a subscript here, a number here, and we don't. And that means that we know that our base is understood to be 10. So this is as if there's a 10 here, even though we don't see it. It's called a common log. So when we switch this from the log format to the exponential form, we get my base 10 to my exponent 2 equals the 5x. That's the answer in the question asked in exponential form. And now we can figure this out because 10 to the 2, 10 squared is 100. So this means 100 equals 5x. And in order to find out what x is, we're going to divide both sides by 100. And then we get x equal to 20. I think I saw a couple of answers giving me 20. Cheryl certainly wrote 20 for that. I think, let me see who else wrote 20 as the answer. Stacia, you're just the opposite. The number
Yeah,
one,
because of the way I wrote it down. So 1 should be 2 and 2 should be 1.
right? Okay, so now let's look at question number 2. So question number 2 is, we don't know what this is, so I'm going to call that my x. Let's call this our x. We don't know what it is, so let's call it x. They wanted me to figure out what's the log of 216 in base 6s. And again, we're going to change it to exponential form by doing 6. It's my base, because that's my subscript, to the x exponent equals 216. And this is similar to some of the other questions that we did. It's really an exponential equation now. We're trying to find out how many times should I multiply 6 by itself to get 216. So again, I like to do these with my fingers. 6 times 6 is 36. If you don't know these numbers by heart, you can take out your calculator. So, and then if we multiply 6 by 36 by 6 again, that's when we get to the 216. In other words, the x would have to be equal to 3. The exponent, if you try 6 to the exponent 3, or if you multiply 6 times 6 times 6, that's when you're going to get 216. So the answer here is 3. So the answer to the first one was 20, and the answer to the second one was 3, because that's how many times we have to multiply the 6 by itself. Now, we're not multiplying 6 by 3. We're multiplying 6 times 6 times 6. It's how many times we're multiplying the 6 by itself. That's what the exponent of 3 is telling us. Okay.
Professor,
Yes.
so the way I did it was I times the 6 by the 36. 6 times 36 gave me the 216, and then I divide the 6 by the 36, that gave me 6.
Okay, but you're trying to do too many things. What you have to do is just, when you're answering a question like this, all you have to do is start with your 6, and you do 6 times 6. Now that gives you your 36. So with 36, it's not 216, so I have to go another time. So I have to multiply another time. So it'll be 36 times 6. That'll give me the 216. That's why I have to multiply the 6 3 times. That's how, you understand that better?
Yeah, I see now.
Okay, because it has nothing to do with 36. 36 is not the number you're looking at. The number you're looking at is the 6s.
Yeah, I see that now.
Okay. There is one other type of question I'd like to go over with you on in terms of logs. And that has to do with, these were all log equations if we have an exponential equation. So I'm going to erase this. What does an exponential equation look like? Well, here's an example. Something like this. 5 to the 10 minus 2x equals 625. This is called an exponential equation because we have a exponent, our variable in the exponent. The x is in the exponent. And if you recall what I said to do in these type of equations is you try to put both sides in terms of the same base, in terms of an exponent to the same base. Now here, it's obvious that the base I'm using is 5. 5 is the number that's getting the exponent. So let's try and put the 625 in base 5 as well. So let's see. Here's my fingers again. 5 times 5 gives me 25. 25 times 5 gives me 125. And 125 times 5, we're now up to the 4th time. That's when I get to the 625. And you can try this again on your calculator. Count it. 5 times 5, 25. 25 times 5, 125. 125 times 5 is 625. You have multiplied 4 5s. So this is the same as saying 5 to the 4th power. So this stays the same. It's 5 to the 10 minus 2x power. And this we rewrote as a base of 5 with an exponent. It turned out to be 5 to the 4th power. You could always check if you've done it right by actually on your calculator, taking your 5, pushing your exponent button, putting in your 4, and seeing that what you do get is 625. Once these are both written with the same base as they are now, you don't have to worry about the base anymore. Now you just work with the exponent. The exponent of here is the 10 minus 2x. That has to equal the exponent of here, which is the 4. In other words, we now can ignore that 5 because it's the same for both of them. Let's look at what the two exponents are. And of course, now it's just a regular algebraic equation. I'll subtract 10 from both sides, which will give me negative 2x equals 4 minus 10.
Minus 10, which is negative 6.
Is negative 6, correct?
And then negative and negative give me a positive 3.
Right. So that in the end, my answer comes out to x equaling to 3, and that would be your answer. So this is solving a exponential equation.
Good morning, Professor.
Hi, Devana. Good morning. Did you have trouble getting on?
Yes, I did.
I'm sorry, I was in the middle of muting you. Let me unmute you.
Yes, I did have trouble this morning.
In what way were you having trouble? Because a few people are telling me they had trouble.
My passcode, every time I put the passcode in, it kept saying it was incorrect.
And you were using lowercase letters.
Yeah,
Because Melissa said the same thing, and I don't know why that. I think what I'll do for next time is maybe I'll switch the passcode. Maybe they expire. I don't know, and put in go back to one of the original passcodes. I'll let you know, but look on your emails to make sure that if the passcode has changed. I see that our attendance is quite low, so I don't know why that is. All right. I'm glad you got in now.
thank you, me too.
Okay. So this was what we called an exponential equation. I want to show you another type of exponential equation and an alternate method of solving it. Okay, so let me take a different exponential equation. This was a case where we had an exponential equation because the variable was in the exponent. That's where our x was. And we were able to put both sides in terms of the same base. Once we were able to do that, then we were able to solve the equation. What happens if we have a situation like this? I'm going to try an easy one. Suppose I give you something like 3 to the x equals 15. Now, if I try to do the same thing on this one, I would want to, this is written in base 3. We would like to get this in base 3 as well. Let's see what happens when we go to base 3. Remember when I mean base 3, it means 3 to some exponent. 3 times 3 is 9. Okay, we still have to go further because 15 is more. But 9 times 3 is already 27. We never hit 15. Either was less than 15, 3 times 3 was 9, or was more than 15, 3 times 3 times 3 was 27. It makes sense that the x is someplace between the 2 and the 3, but how do I figure this out? How do I figure it out when the two numbers cannot be put into the same base? So here's an alternate method, and actually you could use it on the other exponential equations as well. I think that the way we did those are the easier way, but certainly when you can't express both numbers in terms of the same base, what you could do is take the log of both sides. What do I mean? Write the word log in front of each of these numbers, which makes sense. If 3 to the x equals 15, when I'll use log, if I knew what the number is, I could put it into my calculator. They're the same number, so their logs, their exponents, remember the logs are exponents, are going to be the same number as well. Now, okay, that makes sense maybe, but why does it help us solve the equation? Because one of the rules that we have with logs has to do with the fact that when you have an exponent, in logs, the exponent becomes the coefficient. Remember our 3 rules of log arithmetic, so to speak, is that when you're multiplying numbers, you add the logs. When you're dividing numbers, you subtract the logs. And when you're have an exponent, that exponent becomes your coefficient. So this then becomes x times log 3 equals log 15. We've made our exponent, which was sort of up in the air, and we want to get it down on the ground by bringing it in front as a coefficient. And now I just want to get the x alone, so I'll divide both sides by log 3. So that it turns out that my x is equal to the log of 15 over the log of 3. And now I must go to my to my calculator because I can't do this without a calculator. Make sure your calculator is on and press your log button. And when I press my log button, it automatically opens up a parentheses. If yours doesn't, you should put in a parentheses. Put in the 15, close the parentheses, press your divide button. These are my buttons. Log, parentheses, 15, close parentheses, divide. I want to press the log button again and put in the 3. Of course, close the parentheses and press your equal or enter, whatever it is. So log 15, close parentheses, divide, log 3, close parentheses, enter. And of course, you're going to get a long decimal. Now, most of the time, they'll tell you what they want the answer to be. Let's say they want the answer to the nearest hundredth. They will tell you. It could be the nearest hundredth. It could be the nearest tenth. It could be the nearest thousandth. What you have to do, and here's what I got, 2.4649. I'm writing the whole thing that I got here, 73521. Now this really is not the end of it. It keeps going on and on and on. This is an irrational number. It's a non-ending, non-repeating decimal. But they wanted it to the nearest hundredth, which means 2 decimal places. So after I put a line after my second decimal place and look at the number immediately after it, which is a 4. Since it's not 5 or more, I just leave this and my answer becomes to the nearest hundredth 2.46. This is how you can solve an exponential equation by going to logs. Look at what we did. When we had a log equation, we went to exponents. We went to exponential form. When we have an exponential equation, we can go to logs, just the opposite. Those are opposite, or what we call inverse operations. And that's what we always do. When we have x multiplied by something, we divide. We always do the opposite operation. So we're really doing the same thing over here as well. Okay, I'm going to give you one to try also. Erase this now so you can. Let's say the 5 to the 2x equals 17. See if you could find x to the nearest tenth. Any questions? Okay. I don't know.
Professor, I got 1.76, but I'm not sure if that's correct.
Okay, let's see. Let's do it together.
Okay.
Okay, so if we're doing it together, again, we see the base here being used is 5. And when I go to the 17, 5 times 5 gives me 25. I never get to 17. So that's when I know I have to put this word log in front of both of them. So it's going to be log 5 to the 2x equals log 17. And now that I have the word log in front of them, I can use the rules for logs, which means the exponent. I can't do it over here because I don't have logs, but here I have logs, so I can make the exponent, the 2x, the coefficient. So this becomes 2x, goes in front, times log 5 equals log 17. And we're going to divide by the log 5 because we don't want this over here. So over here, we're going to be left with 2x. Over here, now I have to take out my calculator. I can't do this without a calculator. I'm going to put in log. Press my log button, put in 17, close my parentheses, divide. Press my log button again.
I got 1.7603.
And I get 1.760374428. I'm writing the whole thing I see on my calculator. And I'm almost finished, but this is not what x is. This was a 2x because there was a 2 in front of here. So now I'm going to have to divide this by 2. So I'm going to
For
divide.
that, I got 0.88.
Okay. And that gives me 0.880187239. But I wanted it to the nearest tenth. Now the nearest tenth is right over here after the first decimal. And that's 0.8 is the first decimal, but the number after that is an 8, which means I have to increase it. So my answer to the nearest tenth is 0.9. Are you okay with that now?
Yeah.
Okay, good, Stacia. Okay, so April 1.76 was what 2x is, and this is a little bit of a trick because I didn't know on 2x, I wanted what x is, so afterwards I had to divide it. After I did that, I have to then divide by 2.
Yeah, that's the part where I was confused, Professor, because I didn't know if I should divide the 1.7 by 2 or just leave it at that.
No, okay, so now that's why I gave one that was a little bit different. So this is, they're not so hard to do. If you notice, you're getting strange answers, you're getting decimal answers, but that's because these numbers can't be put in the base over here. So we can solve a exponential equation, even if we can't put them in the same base, by using this trick of going to logs. Because in logs, what's an exponent, it becomes a coefficient, and then you just have a regular equation. Let's do one more question. Let me see if I can find it. The question I wanted to do. Now I'll make one up. And that's the question asks, how do I expand something? So I'm going to give you 2 questions to do. First, let's write this in what we call expanded form. That's number one. We're going to take log base 2 of x times y to the third divided by the square root of z. And we want to write it in expanded form. We want to write it log x, log y, log z separate. We don't want it all put together like that. And that's number one. And the second one we want to do is just the opposite. We want to contract. We want to put this back into a single log. Let's say I have something that looks like this. We want to write this as a single log. We have 2 log base 3 of x plus 1/3 log base 3 of y minus log base 3 of z. These are 2 different things that we want to do. Here we have a single log. We want to open it up to a bunch of logs. Here we have a bunch of logs. We want to go back to a single log. I'm going to give you a few minutes to see if you could do it, and then we'll do these together. In the meantime, I'm going to try calling Melissa and see. Hi, Melissa. You still couldn't get on. I'm wondering if you would just go to zoom.us and just put in our number. Instead of, right. Maybe, I don't know, a few people have said they were having trouble getting on, but there are like 13 people on, so it's not, see if you could go to zoom.us and put in the 806-435-5099. That, go to join meeting and then. It's not giving you join meeting. Oh, so strange that it's giving you trouble now after the whole term. No. No spaces. Okay, great. Okay, good, thanks. Okay, Melissa,
Yeah,
I'm gonna make you the host.
already. Thank you.
Thank you. I don't know there's obviously something wrong with, oh, I'm
Five.
Luke, that's what happens when I try to make somebody the host. Luke, I made you the host by mistake. Luke. Can you, Luke, can you go and make Melissa the host?
Sorry, I got logged out.
Oh, I still see you on.
No, I was logged out. I just logged back in.
Oh, okay. Somehow. Okay, I'm gonna reclaim, okay. I'm the host again. Okay, now, I guess that's what happened. I tried to make you the host and, okay, I was trying this again.
We
Yeah.
good?
Okay, you're a host now.
Okay.
Okay, thanks. You're just gonna have to turn off the recording when we.
Okay, no problem.
Sorry for, okay, so now that everybody had time to do that while I was trying to help people get on. Let's see how we can expand something like this. Now, if you recall, what I said first is, anytime you see a radical in your expression, you've got to rewrite that as an exponent because we don't recognize radicals in the log chapter. We just recognize exponents. So we could rewrite this as log base 2 of x y to the third over z to the 1/2 exponent. The 1/2 exponent and the square root mean the same thing. If you had a cube root, just remember this, the square root is the same as a 1/2 exponent. A cube root, for example, one with the index of 3 is the same as a 1/3 exponent. So we can always write our radicals as exponents. Once we have that, we then look for any places that we have multiplication or division. And I see that I have two things multiplied, the x and the y third. We know when we go to logs, it's going to be added. And we're dividing by the z to the 1/2, so we're going to have to subtract in logs. Remember, multiplication in logs converts to addition, division converts to subtraction. So therefore, this will become the log base 2 of x plus the log base 2 of y third. We've converted this multiplication. Remember, when things are directly next to each other, it means they're being multiplied to a plus, minus the log base 2 of z to the 1/2. That's our first step. When we're expanding, look for your multiplications and put pluses between the logs. Look for your divisions and make them minuses. And then go back and see if you see any exponents. Well, On the x, there's no exponent, so that stays the same. So that's log base 2 of x. But here the y does have an exponent, but we know when we have an exponent, the exponent in logs becomes the coefficient. So this.
Good morning, Professor.
Yeah. Who just said?
Denisha.
Oh, wow. Welcome.
Hi.
Nice. Okay. I'm in the middle of doing a problem. So this, the 3 is an exponent. In logs, that's going to become your coefficient. So it's going to be 3 log base 2 of y. And the z also has an exponent. It has an exponent of a half. So this becomes again, the exponent becomes the coefficient. It goes in front of the word log. So it becomes minus 1/2 log base 2 of z. So here is the expanded version of this. Again, where we saw multiplications, we added their logs. Where we saw divisions, we subtracted the logs. And where we had exponents, they became the coefficients. This bottom one is doing just the opposite. It's already expanded. How do we go back to the contracted, the single version? Well, we follow steps backwards. Over here, the second step we did was we took the exponents and make them the coefficients. So when we're going backwards, we want to take the coefficients and make them back into their exponents. So therefore, this becomes log base 3 of x to the 2 power, because this had a 2 coefficient, plus log base 3 of y to the 1/3 power, minus log base 3 of z. So the first thing we do is take care of the coefficients, put them back as exponents. The second step is to look for where I have pluses, multiply the things, and where I have minuses, subtract. So I have to put this word log base 3 once, because we want only a single log. We're going to do the x squared times the y to the 1/3 and divide it by the z. Plus became multiplication, the minus became division. Usually we don't leave an exponent as a fraction, so probably the better way to write this would be to write log base 3 of x squared. The 1/3 exponent is the same as the cube root of y over z. So this would be the contracted version. Remember, this 3 here is the index. It's inside that little check mark. X squared times cube root of y divided by z. So that's how here's how we expand, here's how we contract. Just working these steps backward to go back to this. Okay. I think this pretty much takes care of the type of questions you would see on logarithms. We basically have completed all the material for the final. I'm going to be doing review for the rest of the week. Don't forget, our final is on Thursday, a week from this Thursday, May 20th. This Thursday is going to be the 13th of May, and a week later, the 20th, between 10 and 12. Just like we usually have class at 10 o'clock, we'll have our final at 10 o'clock. If you have any reason that you cannot take it at that time, you must let me know so I can set you up for a different time. I can set it up on Blackboard. The final is on Blackboard. Our classes this week are going to be on Zoom, but our final is on Blackboard. I will be available if you have any technical difficulties, but you've taken tests on Blackboard before, so you should know how to get into it, etc. Also, I spent a lot of time figuring out what your present average is based on the work that you've completed. If you do more quizzes, if you're missing quizzes, if you haven't done a total of 5, then out of the 6 that I gave, then you are going to get, your average is going to go down significantly. If you had a bad mark, but you did all 6, I always drop the lowest mark. If you only did 5 and you had a bad mark, you will either want to do another quiz or redo one of the quizzes. If you want to anything reset, all you have to do is send me an email telling me to reset something. I will reset it for you. You can't, if you tell me on class today, I'll forget. I'm sorry, my memory is not what it used to be. Send me an email. Does anybody have any questions before I go on to reviewing of trigonometry?
I do, Professor. Is it possible I could take the quiz over?
Yes, it certainly is. Just all you have to do is send me an email and I will reset it for you.
All right, I'm gonna send you an email.
But you have to send me that email.
Professor.
I'm pretty good about it.
I copied down, I got 3 questions wrong. I copied the questions down, but mostly it was on log, what I got wrong, and only on graphing.
Okay. Then you must be talking about the practice final.
No. It was the quiz that I took.
Is it
The last one you posted on Blackboard, that quiz.
I posted 2 things on a 10 question.
It was the 10 question one.
Oh, it had no log on.
It did. Wait.
It was on conics and trigonometry. It was on conic sections, the graphing of conic sections, and it was on trigonometry. It didn't have any logs in it.
Let me figure it. Hold on.
Okay, whatever it is, just check it after class and send me an email. If you want them both reset, I'll reset both of them. I'm perfectly happy to reset anything you need to reset. Is there going to be any more work on Delta? No, there were a total of 21 homeworks on Delta Math. If you did 15 or more, and when I said did, even if you just touched it, if you just you got 50, 30% on it, it's considered done. You have to forget the full 15 points on the homework and participation part of your final grade. You had to do at least 15 homeworks, and of course you had to be attending class. Now, if you didn't attend class, but you did all the homeworks, then I'm probably going to give you the 15 points anyhow, but really you're supposed to have been attending class as well. That's what that 15% is. 10% is homework and 5% is participation, but I put it all together as 15 points. So if you see, I enumerated the amount of homework and participation is 15 points, you got 10. That means you could up to 5 points more if you do more homework. So if you did not get a full 15 points on the homework, and those are points that are really going to count for you, because when in the end, I add it all up. I do it by the books. some people I give extra credit, like if somebody did all 21 homeworks and came all the time to class and answered questions, I have on my thing, EC, extra credit. How I use the extra credit depends on your final grade. Somebody with extra credit whose average is, let's say, 77, I'll probably bump up to an 80 so that they can get a B. So the extra credit is to increase your grade. Now, if your final average is 99, and there are some people who are close to that here, then extra credit is not going to help you too much because you can't go much higher than 99. So the extra credit is really for the people to bump up your mark, to give you a better grade. So, but if you really have not been doing the quizzes and the homeworks, the homeworks are 15%, the quizzes and tests are another 25%. So 40% of your mark is what was done on Delta Math and on Blackboard. If you didn't do that work, you're not getting that 40%. It doesn't matter what you got on the midterm and the final. You have to have done the other work in the class.
Professor, I have a quick question.
Sure.
So as far as the homework goes, I've done a lot of the homeworks, but only a few say complete. So does that matter?
Does not matter if they're complete.
No. It shows me like in blue, completed, and then some of the homeworks it doesn't say that. It just has like checks on it.
You know what? Send me an email about this. I'll check. I can open up your account and I'll see what it means.
Okay, thank you.
My feeling is if you tried a homework and you weren't able to do it, but you tried it, you get the homework credit. Homework credit is not a mark as to how well you did the homework. Did you do the homework? That's what the homework mark is. Okay. Okay, so again, check your Delta Math accounts to make sure that you can see what you've done. Just like I can go, what happens is I go on to each of your accounts and I can sign in as you. I know this is, you're gonna say there's no privacy here, but I can see exactly what you've done on your Delta Math account. And if you've made attempts to do the homework, you're gonna get the homework credit. The quizzes and tests, the marks count, but not the homework.
Professor, you were right. I need the quiz to be resetted. What I got wrong on logs was on the final, but I want to take the quiz that you just posted. I want to take it over again.
Okay, so just write that to me, okay? Just write it, because unfortunately I do forget and I don't want to forget. When I see it written on black and white, then I do it immediately. Okay, so let's now go over the type of questions we might see that have to do with trigonometry. Too many papers at this point. So let's first go over the type of questions that would be on Pythagorean theorem. Let's say I gave you a question that looks like this. We give you a triangle. Here's my A, B, and C. They actually put that in. They put, they want you to find out what is C if A equals 8 and B equals 15. Okay, I'm going to give you a minute to try this out. See if you can find that out.
Professor, did you write down the like the formulas for log and all of that already in your previous classes, or you
Yeah.
did it today?
Yeah, I did.
Okay.
And don't forget, okay, I mentioned it to other people. If you go on your Blackboard account, I think in the information section, you're going to see that there's something called a study guide for Math 136. This is something I worked out for previous Math 136 classes. It's about 6 pages of the different formulas and type of problems. If you don't see it, email it to me. I'll tell you, and then I'll email it to you directly. If you don't see it on your Blackboard account, but this is it has questions on it. It's got all the formulas that you need. It's 5 pages on your, as I said, it's on the information page of your Blackboard account. Just look for review of Math 136. If anybody is not sure and can't find it, just let me know. I will send you a copy directly on your email, okay? Okay, so let's see if we can do this problem. First of all, I only have the capital letters written here. Let's remember how we put in these lowercase letters. The capital letters stand for the angles, the points. The lowercase letter stands for the whole side. And since this side is across from capital A, this is what we call small a. This one side is across from the capital B, so this becomes a small b. And this side is the small c. This is what we call a right angle. Usually put a little corner, square corner in it to indicate it's a right angle. This is called, the Pythagorean theorem works like this. A squared plus b squared equals c squared. This is a rule, a formula that you can use when you have a right triangle and you know 2 of the sides of the right triangle and you want to figure out the third side. So in this case, the A they told me was 8, so it's going to be 8 squared. The 15, this is 15 squared, equals c squared. Now, let's see. So 8 squared we know is 64. And 15
So 15
squared
is 225.
is 225. That's what my C squared is. Now, when I add these up, I get
289.
That's not my answer though. That's what C squared is. I don't,
Find the
you
square
don't,
root of
what is it?
17.
Comes out to 17. If you do the square root of 289, you will see that you get the answer 17. So the third side of this triangle is 17. So if that's the only question you're asked, that's using Pythagorean theorem, it helps you find the third side of a right triangle when you know two sides. Any question about that? Okay, thank you, Stacia. That was perfect. All right, so now let's try a different type of a problem. I'm going to give you a different type of a problem, also about right triangles. What if I gave you this problem? Also right triangle. They tell, here's my right angle. They tell me this is 21 and this is 25. And this angle is the angle we called theta. Remember that it looks like a 0 with a line through it. It's the name of the, what if they asked me to find the secant of theta? And we're going to find it in two ways. We're going to do it as a fraction, and we're also going to do it as a decimal. How do we find the secant of an angle? So there are two things that you must remember. And my feeling is before you start a test, it's going to have trigonometry on it. You're going to write out these on your top of your paper. SOHCAHTOA. Which stands for the sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. The tangent is opposite over adjacent. That tells us what we need to know in order to find either the sine, the cosine, or the tangent. But they didn't ask me for any of those three. They asked me for the secant. So the sine and the cosine and tangent are primary trigonometric functions. The ones that are not so important, the secondary ones, are the cosecant, the secant, and the cotangent. The cosecant is the reciprocal of the sine. The secant is the reciprocal of the cosine. Notice this starts with S, so its partner starts with C. This starts with C, so its partner has to start with the S. And the reciprocal of the tangent is the cotangent, which is really easy to remember. Tangent, cotangent, they seem to go together. But sine pairs with cosecant, cosine pairs with secant. So when they ask me to find the secant of theta, the first thing I'm going to do is find the cosine of theta. Because if I find the cosine, I'll just flip it over and that'll give me the secant. So the cosine, remember we said, is cot, adjacent over hypotenuse. So let's see where we are here. Here's my angle theta. This is what we call the opposite side, because it's across from the theta. This is our hypotenuse, because it's across from the right angle. The side that's connected to the angle, the one that's not the hypotenuse, that's the adjacent. In order to find the cosine, we need both the adjacent, which we have, it's 25, and the hypotenuse. We don't have the hypotenuse. So the first thing I have to do is figure out what is the hypotenuse. And I can figure out what the hypotenuse is by using the Pythagorean theorem. This is by a squared plus b squared equals c squared. 21 squared plus 25 squared equals c squared. Okay, here comes my handy calculator. 21 squared is 441 plus 25 squared
That's 625.
is 625. So let's add those together.
That's 1066.
Right, so we get 1066 equals c squared. So c is the square root of 1066. Let me see if that's.
The square root is a decimal, Professor. The answer is a decimal.
So we can just leave it in radical form because it doesn't come out to be a nice number. So this is what we're calling the square root of 1066. So the cosine of theta is going to be adjacent, which is 25, over hypotenuse, which is square root of 1066. But again, we didn't want the cosine, we wanted the secant. So right away, to find the secant, I just flip this over. The secant is the reciprocal of the cosine, so it's the square root of 1066 divided by 25. This is your answer as a fraction. It's an answer that has a radical in it. It's the square root of 166 divided by 25. Notice how we did it. We needed to know SOHCAHTOA. We didn't know cosecant, secant, and cotangent. We needed to know the Pythagorean theorem. If they ask you to give the answer in a decimal form, which they might, then you're just going to do that. You're going to take your square root of 1066, make sure you get out of the square root, and divide it by 25. And let's say they ask you to give the answer to 2 decimal places. Now, what I'm getting on my is 1.305986217. Let's say they may ask you to give it to the nearest hundredth, then you would stop after 2 decimal places. Since the third one is a 5, we have to increase it, so it would be 1.31. That would be your answer in decimal form. This would be your answer as a fraction. This is an exact number. This is a number in decimal form. Is this clearer now? Okay, let's do one more question. One more question. We have about 5 minutes, so let's do one more question on trigonometry. Can I erase this? I'm leaving this up here because we're going to need it. I have to tell you, you must know this by heart. You're not going to be given this on your test. You have to have it. suppose I gave you this question. I'm telling you that the tangent of theta is 1/3. And I want you to figure out what is two things. What is cotangent theta? And I also want you to find out what is cosecant theta. Now, one of these is very easy, and that's the cotangent. Because we know the tangent and the cotangent are pairs, they are reciprocals of each other. I don't have to do any work. If they give me the sine and ask for the cosecant, just flip it over. If they give me the cosine and ask for the secant, just flip it over. The same thing. If they gave me the tangent to find the cotangent, I just have to flip it over. The cotangent then would be 3/1, or just 3, because the cotangent is the reciprocal of the tangent. So sometimes these questions are really quite easy. You just have to know that the cotangent is the reciprocal of the tangent. But they also asked me to find, or I also ask you to find, what is the cosecant of theta? So that involves a bit more work. We have to draw a triangle. And let's make this our theta. Remember, I usually put the theta there. The only reason it might be someplace else is if they put it someplace else. But if I'm dealing with it, I always put it down here. Now, remember, in terms of theta, this is my opposite. This is my hypotenuse. This is my adjacent. Opposite because it's across from it. It's hypotenuse because it's across from the right angle, and adjacent because it's next to the angle. Now, the tangent happens to be TOA, opposite over adjacent, which means if the tangent is 1/3, I can pick the opposite side to be 1, and I can pick the adjacent side to be 3. Then I get my 1/3. So I'm going to pick in my triangle this to be my 1, because that's my opposite, and this to be my adjacent. Here's my 3. Now, in order to find the cosecant, I first have to find its partner, the sine. Now, the sine, we know, is opposite over hypotenuse. So in this triangle, I know what the opposite is. I know what the adjacent is, but I don't know what the hypotenuse is. But I can figure that out using the Pythagorean theorem. It's 1 squared plus 3 squared equals c squared. A squared plus b squared equals c squared. So this is 1 plus 9 equals c squared. So my c squared equals 10, which means the c is the square root of 10. So the sine is the opposite, which is 1, over the hypotenuse, which is square root of 10. So the cosecant, once I have the sine, I can just flip it over and I get the square root of 10 over 1, or just the square root of 10. And that would be my answer. Yes, there are a lot of steps, but they're all, if you notice, all the questions were very similar. Okay, I am going to, that's the end of class. Melissa, you staying on?
Professor, give me a minute to write that off, please.
The elites of the world created a system where you get where you forget about your dreams because you're so focused on making ends meet. You forget about the dream that God gave you because you're so focused on
Melissa,
Yeah.
you forget about
are you having class now?
Sure.
You want to do this, you want to do that. You want to do
Okay.
Professor, I have a question.
Yes.
this.
It's Jennifer. I wrote down 4 problems that I had problems with and I got wrong. So I wrote them down on a piece of paper. So on, I guess, Thursday, I'll come in at 9:30 and I can maybe help me out.
Listen,
I can also, if you want to do it for the whole class, I can do it for the whole class.
Yeah, it's I'm pretty sure somebody else probably has the same problem as me.
I assure you that somebody else will. have the same-
I wrote them down. It's mostly on graphing and tan.
Okay,
So I just have it.
and this goes for everybody else in the class.
For 3 reasons. You need
Right now, we finished all the material. I'm going to be throwing out different examples for us to examine, to review for the final. We basically have to do, for what I haven't covered is radicals and quadratic equations and
This is why we
kind of
have
sections. Those are the things that I really want to completely review. But if you have any questions on anything, any type of questions, bring them up in class or send me an email. Let's get
great generational
so
currency.
that everybody feels comfortable going into that
We
final.
have great generational
And
wealth.
again, make sure you get as much,
Generational wealth with
give
every
you enough time. But I'm not going to give you longer than the 20th. But if you do additional work that I haven't counted yet,
that's all we really
I'm going to recheck everybody's
serve yourself. Let's be real.
accounts. They're both their Blackboard and their
Lifestyle for
the
the
math account, and I'm going to check to see if you've done more work. I will
we're blessed because
adjust your average. So I'm going to do that
we create a generational wealth.
shortly after you've taken the final. And then, of course, I'm going to include your final grade. So you really have until, let's say, the 19th.
You have to be somewhere at the
If
exact
you need a date extended,
because he ain't even have
I think I made the due date of everything the 14th. But really, you can have until the 19th.
Hey, bro, change your plans. Meet me here. Like
Okay?
that type of stuff. So think about.
I'm leaving Melissa in charge. And Melissa, do me a favor.
Like the lack of this.
Okay.
Now we live in a world where
I think it's.
Yeah.
there's
I think, is that your